You may recognize this formula, maybe a little different version, something you've seen before in science or in physics. This gives us the position of a free-falling object. So S of t is our final position. It's where it ends up after a certain amount of time. G is the acceleration due to gravity. And that's a negative acceleration, negative 32 feet per second squared, which we'll use most of the time feet, or negative 9.81 meters per second squared. But again, most of the time we're going to be dealing with feet for these problems. V sub 0, that's our initial velocity. Right, that's why we have the 0, that's the velocity when time is 0. And S sub 0 is the initial position. Alright, so we're going to need this formula for the following problem and for some future problems. So this is one that you're going to want to know for later on quizzes and tests. It says a ball is thrown vertically upward at time t equals 0 with an initial velocity of 96 feet per second. So v sub 0 is 96 feet per second from an initial height, so s sub 0 equals 112. Part A asks us what's the maximum height attained by the ball. So first, let's use what we've got to set up our equation. We've got our final position is equal to 1/2 times g. Right, we're talking about feet here. So 1/2 times negative 32 gives us negative 16 t squared, plus our initial velocity is 96 times t, plus our initial height is 112. So we've got our equation. This represents the position of the ball at any given time. We want to find the maximum height. Well, this is a parabola, right? Negative leading coefficient, so that tells us that parabola is opening down, so our vertex is going to be the maximum. So what we need to remember is how to find the x-coordinate of the vertex. That's going to be opposite of b over 2a. Right, that's the x-coordinate of the vertex, or in this case, the t-coordinate. That's going to be our time. So t equals opposite of b, negative 96, over 2 times negative 16. So negative 96 over negative 32. T is going to be 3 seconds. But that doesn't answer our question. It asks what's the maximum height. That tells us the time it takes to get to that maximum. To find the actual maximum, we have to put that back in. Right? S of t tells us the position. We want to know the position at its maximum. So we want to figure out what's S of 3. If we go ahead and calculate this, we should get 156 feet. That's our maximum height. That's the highest point of the ball. Alright, so that's our answer for part A. Part B asks, what's the velocity at its maximum height? So, if we want to find the velocity at its maximum height, we want the velocity at that instant, at that specific time. So our time is 3 seconds. Instantaneous, remember instantaneous velocity, we're going to take the limit as h approaches 0 of that difference quotient. So in this case, we're dealing with the change in position. So s of, instead of f of, we're dealing with this function, s of 3 plus h minus s of 3 all over h. So we'd just be putting 3 plus h in place of t, putting 3 in here to figure this out. So it's like problems we've done, but I'm not going to be cruel and make you work this out because those of you that do remember a little physics, what's the velocity at its maximum height? You should be able to answer that without having to do any limits. At its maximum height, this limit is going to be 0, right? As an object goes up, velocity slowing down, slowing down, slowing down. When it gets to that highest point, oops, when it gets to that highest point, velocity becomes 0, and then the velocity starts becoming negative because it's going in a downward position. So since it's at a maximum, we know it's going to be 0. We don't even have to work that out. But if it were at a different point and we wanted to find the instantaneous velocity, velocity at a specific time, we have to use that limit. All right, part C, when will the ball hit the ground? So this has nothing to do with the limit or velocity. We want to know when is the position 0, right? The ground, that final height would be 0. So 0 equals negative 16t squared plus 96t plus 112. So we want to solve this. And seeing big numbers, you might think, oh, we got to use the quadratic formula. It's not going to factor nice, but we can actually factor out a negative 16. And then we can factor this trinomial into two binomials. So we get t minus 7 times t plus 1. So if we set these equal to 0, we're going to get either t equals 7 or t equals negative 1. Well, our time's not going to be a negative 1 second. So the only one that makes sense here is t equals 7. So it's going to take 7 seconds for the ball to hit the ground. Now, last part here for part D. What will the velocity of the ball be at impact? Now, we want to know the velocity at a specific time, at this time right here, 7 seconds. So we're going to take the limit as h approaches 0 of s of 7 plus h minus s of 7 all over h. All right, so we're just using the difference quotient at this time, so 7 is our a value. All right, just a matter of plugging in for right now. I'm going to stop there. We're not going to go through the whole problem, but we could do it the same way we were doing limits yesterday.